Good evening, all. Welcome to today's live discussion session for the NPTEL course Soil Mechanics Geotechnical Engineering I. I'm Reshma R, Research Scholar from the Department of Civil Engineering, IIT Madras. I shall share my screen now. Hope it is visible for you. All right. So let's begin today's session. Here's the first question for today's session. With the increase in cohesion in soil, Option A, active pressure decreases and passive resistance increases. Both active pressure and passive resistance decreases. Option C, active pressure increases and passive resistance decreases. Option D, both active pressure and passive resistance increases. So, when the cohesion in the soil increases, what is the effect on active pressure and active and passive earth pressures? How does it vary with respect to the cohesion of soil? You can type in the answers in the chat box. So when the cohesion of the soil increases, what is the variation that happens to active earth pressure and passive earth pressure? All right, so let's see what is the correct option. So the correct option is option A, that is active earth pressure decreases and passive resistance increases. So let's see how. So by the equation we have active pressure is equal to Ka gamma z minus 2c root Ka, and passive pressure is equal to Kp gamma z plus 2c root Kp. So here Ka and Kp are coefficient of active earth pressure and passive earth pressure. So gamma is the unit weight of the soil and Z is the depth of the soil. And then comes the term C, which represents cohesion. So in the equation for active earth pressure, when the value of C increases, ineffective active pressure decreases. Whereas in the case of passive pressure, when the value of C increases, the value of passive pressure also increases. So, with increase in cohesion, active pressure decreases and passive pressure increases. That is option A. So, moving on to the next question. A retaining wall with smooth vertical back face has to retain a backfill of C5 soil up to 5.5 meters above ground surface. The surface of the backfill is horizontal and its unit weight is equal to 18.5 kilonewton per meter cube. Cohesion C is 30 kilopascal and angle of shearing resistance is 20 degree. The intensity of fictitious uniform surcharge, which if placed over the backfill can prevent the formation of tension cracks, is. So, we are given a retaining wall which has a smooth vertical back face, and the height of the backfill it has to support is 5.5 meters above the ground surface. The unit weight of the soil in the backfill is 18.5 kilonewton per meter cube. C cohesion is 30 kilopascal and the value for phi is 20 degree. We are asked to determine the fictitious uniform surcharge if placed, which can prevent the, or the value of which should be such that it can prevent the formation of tension cracks. So option A 91.17, option B 41.17, option C 55.71, option D 85.71. So which is the correct option? We need to determine the value of the surcharge that can prevent the formation of any tension cracks. So which is the correct option? All right, so let's see which is the correct option. Here, correct answer is option D. So in this question, we are given that the height of backfill is 5.5 meter. Unit weight of the backfill soil is 18.5 kilonewton per meter cube. Cohesion is 30 and angle of internal friction or shearing resistance is 20 degree. So if we have a surcharge Q, the equation for vertical stress at any depth is given by the equation sigma V is equal to Q plus gamma Z. We know that. So now the active pressure equation, if the surcharge is present, the active earth pressure equation changes to PA equal to Ka into Q plus gamma Z minus 2C root Ka. So when Q is 0, this will reduce to Ka gamma Z minus 2C root Ka as we saw earlier in the previous problem. So here, since we have the surcharge condition, the equation has the term Q also. Now, at Z equal to 0, that is at the ground surface, PA becomes Q into Ka minus 2C root Ka. Gamma set term vanishes at Z equal to 0. So, in the question, we are asked to determine the surcharge with such a magnitude that will prevent the formation of tension cracks. That is, at Z equal to 0, active earth pressure is 0, should be 0. So, equating the above equation with 0, we have QKA minus 2C root Ka is equal to 0. So, we have QKA is equal to 2C root Ka, where Ka is the coefficient of active earth pressure and is given by the equation Ka is equal to 1 minus sine phi by 1 plus sine phi. So, here phi is 20 degrees. Substituting, we have coefficient of active earth pressure Ka is equal to 0.490. Substituting back in the previous equation for the active earth pressure at Z equal to 0, we have 0.49Q minus 2C root Ka. So substituting for Ka, we have 2 into 30 into root 0.49. So rearranging for the value of Q, we get 0.49Q is equal to 42 or Q is equal to 85.714. So that is the magnitude of surcharge if placed over the backfill, which can prevent the formation of any tension cracks. So, hope that is clear to you. Moving on to the third question. A smooth, vertical, rigid retaining wall, 5.5-meter high, carries a uniform surcharge load of 30 kilonewton per meter square. The backfill is clayey sand with the following properties. C is equal to 32 kilonewton per meter square. Phi is 20 degrees. Gamma is 18.5 kilonewton per meter cube. The magnitude of the total passive thrust on the wall is. So, we are given a rigid retaining wall that is 5.5-meter high and which has a uniform surcharge load of magnitude 30 kilonewton per meter square. The backfill has a cohesion of 32 kilonewton per meter square, phi 20 degree and unit weight 18.5 kilonewton per meter cube. We are asked to determine the magnitude of total passive thrust. Option A 755.15, option B 923.51, option C 1410.18, option D 1654.17. So, what is the magnitude of total passive thrust that is acting on the wall? Which is the correct option? Alright, so let's see which is the correct option. Yes, answer is correct answer is option C. So we'll see how we have got that. So here we are given that the height of the backfill or the height of the retaining wall is 5.5 meter. Unit weight of that soil is 18.5 kilonewton per meter square. Cohesion is I'm sorry, the cohesion is 32. One second. Yes, cohesion is 32. Yeah. So the cohesion is 32 kilopascal. Angle of internal friction phi is 20 degrees and uniform surcharge load it is 30 kilonewton per meter square. So these are the given values. Now we know that the passive earth pressure PP is equal to Kp into Q plus gamma Z plus 2C root Kp when there is a surcharge load Q acting on the retaining wall. So, the coefficient of passive earth pressure Kp is equal to 1 plus sine phi by 1 minus sine phi. Uh, Sorry, the phi here is, one second. Yeah, it is 20 degree only, sorry. Okay. So, yeah. So, Kp is 1 plus sine phi by 1 minus sine phi. Substituting, we have Kp is equal to 2.041. So that is the value for coefficient of passive earth pressure. At Z equal to 0, we have the passive earth pressure as Pp is equal to QKP plus 2C root Kp. So the Pp value becomes equal to 152.662 and can be represented as shown in the figure. So at Z equal to 0, we have the passive earth pressure as 152.662. Now at Z equal to 5.5 meter, that is at the bottom, we have PP is equal to 360.33. Considering Z value as 5.5 in the equation. So when we represent it in a pictorial way, we have what is as seen in the figure. So now we need to determine the total passive thrust. That is the area of this figure, which is equal to 152.662 into 5.5 plus, that is the area of the rectangle, plus the area of the triangular side, which will give you 1410.728 as the total passive thrust. I hope this,
Option C, madam.
yeah, I hope it is clear to you.
Yes, madam.
Okay, so we'll move on to the next question. That is our fourth question, that is a 5-meter high masonry retaining wall has to retain a backfill of sandy soil having gamma equal to 18 kilonewton per meter cube and phi is equal to 35 degree. The surface of the backfill is inclined at an angle of 10 degree to the horizontal. The magnitude of total passive thrust on the wall is. So here the retaining wall is retaining sandy soil. Backfill is sandy soil and the unit weight is 18 kilonewton per meter cube and phi is 35 degree. Also, the surface of the backfill has an inclination to the horizontal by 10 degrees. So, in all the previous problems, the backfill had a surface that is horizontal, but in this problem, we have a backfill which has the surface inclined to the horizontal at 10 degrees. So, we are asked to determine the magnitude of the total passive thrust on the wall. Option A 453.6, option B 774.5, option C 673.5, option D 843.8. So which one is the correct option? You can type in the answer in the chat box. Okay, let's see how to solve this.
Option C, madam.
No, I think that's option B. Okay, so let's see how it is solved. Okay, so here we are given height of the backfill above the ground surface as 5 meter, unit weight of the backfill soil, that is sandy soil, as 18 kilonewton per meter cube, angle of internal friction as 35 degrees, and inclination of backfill surface to the horizontal as 10 degrees. So here the total passive thrust is half kp gamma h square. We can directly use this equation because we don't have a surcharge here, we don't have cohesion also. So it is half kp gamma h square. Now the coefficient of passive earth pressure when the backfill surface is inclined to the horizontal is given by kp is equal to cos beta into cos beta plus square root of cos square beta minus cos square phi divided by cos beta minus square root of cos square beta minus cos square phi. Now substituting the values we have, kp is equal to 0.9848 into 3.4947, which gives a value of 3.442. And so back substituting in our equation for the passive thrust, that is half k gamma h, sorry, half kp gamma h square, we have the value 774.4. Is that clear?
Yes, madam.
Okay. So let's move on to the next question. A 5-meter high masonry retaining wall has to retain a backfill of sandy soil having gamma equal to 18 kilonewton per meter cube and phi equal to 35 degree. So the retaining wall is exactly similar to the previous question. Now the surface of the backfill is inclined at an angle of 10 degree to the horizontal as in the previous problem. Here we are asked to determine the point of application of the total passive thrust on the wall from the base of the wall. So earlier we determined the total passive thrust. Now in this question we are asked to determine the point of application of this total passive thrust. You can type in the answer in the chat box.
Option A, madam.
Yeah. So I have got another answer also in the chat box as option A. Okay, so let's see which is the correct option. Yes, correct option is answer A. So here we are given the height of the backfill, unit weight of the backfill soil, inclination and angle of internal friction as in the previous problem. So the point of application of the passive thrust is given by h by 3 from the base of the wall. So here h is 5 meters. So substituting we have 1.667 meter from the base of the wall. The point of application is 1.667 meters from the base of the wall. All right. So here we have the next question. A retaining wall with a smooth vertical back retains sand backfill for a depth of 5 meters. The backfill has a horizontal surface and has the following properties. C dash is 0 because it is sandy soil. Phi dash is 30 degrees. Gamma bulk, that is bulk unit weight, is 18 kilonewton per meter cube. Gamma sat, that is saturated unit weight, is equal to 20 kilonewton per meter cube. And water table is below the base of the wall. The backfill supports uniformly distributed load of 21 kilonewton per meter square. The total active thrust using Rankine's theory is. So, here also the retaining wall is supporting a sandy soil backfill with the water table in this situation is below the base of the wall, and a surcharge of 21 kilonewton per meter square is acting on the backfill. Both the bulk unit weight and saturated unit weight of the backfill is also given. We are asked to determine the total active thrust. Option A 84, option B 114, option C 94, option D 110.
Option D, madam.
Okay, so let's see which is the correct option. Yes, it is option B. So we are given that the height of the backfill above ground surface is 5 meter. Bulk unit weight is 18 kilonewton per meter cube. Saturated unit weight is 20 kilonewton per meter cube. Cohesion is 0 and angle of internal friction is 30 degree. Also, the backfill has a load of 21 kilonewton per meter square. Now we know that active earth pressure PA is equal to Ka into Q plus gamma Z. So in the first question we had seen one more term involving C, that is cohesion, but since here it is a cohesionless soil or sandy soil, we are neglecting that term or that term vanishes. So active earth pressure is given by Ka into Q plus gamma Z. Now the coefficient of active earth pressure Ka is given by 1 minus sine phi by 1 plus sine phi when the surface of the backfill is horizontal. Substituting the value of phi, we have Ka, the coefficient of active earth pressure, is equal to 1 by 3. Therefore, substituting for the earth pressure at z equal to 0, that is at the surface, we have Pa is equal to Q into Ka, since gamma z term vanishes as z is equal to 0. So we get Pa is equal to 7 at z is equal to 0. Now at z is equal to 5, we have Pa is equal to 37, which can be represented as shown in the figure. Now, therefore, the total active thrust will be the summation of the areas as we saw in the previous problem. So we have Pa is equal to 7 into 5 plus zero point 0.5 into 37 minus 7 into 5. That is area of the rectangle plus the area of the triangle aside, which will give us a value equal to 110 kilonewton per meter. Sorry, the unit is meter. So we have 110 kilonewton per meter. Now we have the next question. A retaining wall with a smooth vertical back retains sand backfill for a depth of 5 meter. The backfill has horizontal surface and has the following properties. C dash is equal to 0 because the backfill is sandy soil. Phi dash is equal to 30 degrees. Bulk unit weight gamma bulk is equal to 18 kilonewton per meter cube. Saturated unit weight gamma sat is equal to 20 kilonewton per meter cube. Unit weight of water gamma W is given as 10 kilonewton per meter cube. And the backfill supports uniformly distributed load of 21 kilonewton per meter square. The total active thrust in kilonewton per meter length if the water table is at a depth of 3 meter from the ground surface and there is no drainage based on the Rankine's theory. So here also the retaining wall is supporting a sandy soil backfill with the same properties as in the previous problem, except that in the previous problem the water table was below the base of the retaining wall. But in this problem, the retaining wall is at a depth of 3 meter from the ground surface. And also there is no drainage. So the soil is submerged. The backfill is submerged. From 3 meter from the ground surface, it is submerged. So we are asked to determine the total active thrust in that case. Option A 124.67, option B 186.67, option C 106.67, option D 196.67.
Is it
So
option C, madam?
um, maybe some like it is. I think it is not option C. Uh,
Okay, madam. Okay.
yeah,
Mistake.
some values are missing. Like the main problem with these multiple choice question is that all the possible answers, including the wrong ones, will be given. So that is one problem because once we get an answer and if that is there in the option, there is more probability that we will select that without checking once again, right? Okay, so we'll see what is the correct answer. It is option A, that is 124.67, I guess. Okay, so we are given that the height of the backfill above ground surface is 5 meter. Bulk unit weight of backfill soil is 18 kilonewton per meter cube. Saturated unit weight is 20 kilonewton per meter cube. And unit weight of water is 10 kilonewton per meter cube. Cohesion is 0 and the depth of water table below the ground is 3 meters. Also the angle of internal friction is 30 degree. As in the previous problem, here also there is a surcharge load 21 kilonewton per meter square. Now,
Excuse me, madam.
yes,
Depth of the water table below the ground or below the top level of the backfill, madam?
below the ground, ground is mentioned as the backfill only.
Okay, madam.
Yeah.
Done.
Here, when we are talking about this backfill, the ground surface will be the backfill top surface only. Okay. So the active
Okay.
earth pressure, as we saw in the earlier problem, the equation is PA is equal to KA into Q plus gamma Z. So coefficient of active earth pressure Ka is equal to 1 minus sine phi by 1 plus sine phi. Substituting the value of phi, we have active earth pressure Ka is equal to 1 by 3 as we got in the previous problem. Now at Z is equal to 0, there is no change. As we saw in the previous problem, it is equal to 7. Only Q and K comes in the equation. Now earlier, we were calculating only at the top point and at the bottom point, but here we have an intermediate point at 3 meter below the ground surface where where our backfill is having the water table or water table is coinciding or water table is coming within the backfill. Earlier it was below the base of the wall, below the base of the retaining wall, so it was not interfering with the backfill. But here in this case, at z is equal to 3, we have to calculate the active earth pressure again, which is equal to Ka into Q plus gamma z, because the soil is above the water table now also. Only at 3 meter the water table starts, right? Or the water table is at the level of 3 meter. So we get Pa is equal to 25 at Z is equal to 3. Now at Z is equal to 5, the backfill is submerged. That is from 3 meter to 5 meter. That's for a depth of 2 meter. The backfill is submerged. So there we have to consider the submerged uh, soil as well as the soil layer above this water table. Also the pressure exerted by this water. All these have to be included in the equation, which so our equation becomes Ka into Q plus gamma dash Z dash plus gamma Z plus gamma W ZW. So here gamma W ZW is the term for the pressure induced by the water. Gamma dash Z dash corresponds to submerged backfill, and the remaining is the similar one as in the previous equations. So, since the backfill is submerged, we have to take into consideration two additional terms, that is submerged backfill soil as well as the water. So, substituting we have Pa is equal to 51.667 at the level of Z equal to 5. And gamma dash, that is submerged unit weight, is given by gamma sat minus gamma W, or submerged unit weight is the difference between saturated unit weight and unit weight of water. That is this particular term 20 minus 10. Alright. So, total active thrust. As we can see in this figure, all the values we have plotted in the figure. So, we have 7, the value 7 as the active earth pressure at Z equal to 0, 25 at Z is equal to, sorry, there is one change. This is, I had copied it from another one. Okay. Okay, so 51.667 at the point Z is at the level Z is equal to 5. So calculating total active thrust, we have PA is equal to 7 into 3 plus half into 25 minus 7 into 3, that is this area, plus 2 into 25, that is this particular area, plus 51.667 minus 25 into zero point 0.5 into 2, that is this area. So in effect we have 124.667 kilonewton per meter as the total active thrust. Hope that is clear. Okay, so here we have the next question. An unsupported excavation is made to the maximum possible depth in a soil having gamma is equal to 17 kilonewton per meter cube, C dash is equal to 50 kilonewton per meter square, phi dash is equal to 30 degree. The active earth pressure according to Rankine's theory at the base level of excavation is, given that the water table effect is not considered. So here we are doing the unsupported excavation to the maximum possible depth. and the soil is having unit weight of 17 kilonewton per meter cube and cohesion of 50 kilonewton per meter square with angle of shearing resistance as 30 degree. So we are asked to determine the active earth pressure. Also, the water table effect need not be considered in this case. We are not given any details about the position of the water table. So we are not considering that. So option A 45, option B 58, option C 88, option D 118.
Option B, madam.
Option B. Okay, let's
B
see
for
which is
Bombay.
the option. Okay, correct answer is option B. So here we have the cohesion 50 kilonewton per meter square, unit weight of sand 17 kilonewton per meter cube, angle of internal friction 30 degrees, and there is no details about the water table, and we are not asked to consider that. We are asked to neglect the water table effect. So active pressure for the case with the backfill having cohesion or cohesive soil is Ka gamma z minus 2c root Ka, as we saw in the first question. So here Ka active earth pressure coefficient is equal to 1 minus sine phi by 1 plus sine phi. Substituting phi as 30 degrees, we have coefficient of active earth pressure is equal to 1 by 3. Now, we don't know the value for z. So, it is given that the excavation is made to the maximum depth possible. So, the maximum depth possible is given by the equation Hc is equal to 4c by gamma root Ka. Substituting the value for cohesion, unit weight, and coefficient of active earth pressure, we have the maximum depth possible as 20.377 meters. So, substituting this value for Z, we have the active earth pressure as 57.735, which is approximately 58, that is option B. Okay, so we have our last question, that is a 3-meter high masonry retaining wall has to retain a backfill of sandy soil having a unit weight of 18 kilonewton per meter cube and an angle of internal friction of 35 degrees. The surface of the backfill is inclined at an angle of 10 degree to the horizontal. The magnitude of active thrust on the wall is. So here also we are given with the backfill with a surface inclined to the horizontal at an angle of 10 degrees. And the height of the masonry retaining wall is given as 3 meters and unit weight is 18 kilonewton per meter cube. We are asked to determine the magnitude of active thrust on the wall. Option A 24.34, option B 46.57, option C 31.64, option D 22.84. So which is the correct option? So here there is no effect of water table or there is no surcharge. Also, since the soil is sandy soil, the cohesion is zero. So what is the magnitude of active thrust? Okay, let's see which is the correct option. Option
Option
is
D, madam.
which, yes, option B, that is 22.84. Okay. So we are given that the height of the retaining wall is 3 meters, bulk unit weight of the backfill soil is 18 kilonewton per meter cube, angle of internal friction is 35 degrees, and the inclination of the backfill surface to the horizontal is 10 degrees. So the total active thrust is zero point 0.5 Ka gamma h square, as there is no cohesion surcharge. Now, the coefficient of active earth pressure is given by cos beta into cos beta minus square root of cos square beta minus cos square phi divided by cos beta plus square root of cos square beta minus cos square phi. Substituting the values for beta and phi, we have Ka is equal to 0.9848 into 0.286, which is equal to 0.282. Substituting in the equation for active thrust, Pa, sorry, the representation is wrong here. So Pa is equal to 22.84, which is option B. So that was the last question for today. If there are no doubts, then we can close the session.
Madam, small doubt, madam.
Yes,
It, madam, in active and passive and rest condition, when you compare three conditions
yes.
for for a granular soil,
Granular soil, you mean a sandy soil?
yeah,
Oh,
sandy soil, when you are comparing
oh.
active, rest, and passive conditions,
Hmm.
for active condition, when soil moves away, soil will be in tension.
Okay,
In passive condition, the wall is pushing the soil, therefore soil will be in compression.
okay.
Now in rest condition, I don't have idea about exactly the soil will be in tension or compression or what is the status of the soil.
No, at rest there is no movement itself. So there is no um, like such this thing like compression or tension is not actually happening, right?
But there should be at least soil should be belonging to either of these two cases, now, madam. Soil should be either in tension or it should be in compression. Without these two, in what is the state of the soil, madam?
Like you can say it is in a balanced state maybe because there is no movement literally, right?
Yeah, that is
Like
correct, madam. Non-yielding wall.
yeah. So only like tension will happen only if one force is pulling you out or pulling something out, right?
Yes, madam.
Since that is not happening here, we can't say like there is act like whether the soil is in tension or compression. There is no such thing like soil is what to say, like soil is in tension or compression when is it at rest, when the retaining wall is at rest.
It's not possible to determine, madam. Indirectly, not possible to state about.
Indirectly maybe, no, if maybe some field experiments can
Hmm.
determine that, but I'm not sure about that.
Because, madam, my doubt is if there is no any tension compression,
Hmm.
then there should not be any force on the wall. There is a force on the wall. There's a K0 gamma H.
Yes, yes, that is because,
Uh,
like, see, the force will be there on the wall because of the what do you call the backfill weight is acting towards the wall only that time also, right?
yes, madam.
So that will be there.
Mm-hmm. That's the it is difficult to understand for me. There is
Okay.
a force, but we
Hmm.
don't know what is the soil state.
Or whether it is in whether that force is compressive or tensile, we are not able to understand, right?
Yes, madam. Yes,
Okay,
madam.
some in some cases there is like that maybe the state of force may be neither compressive nor tensile. That kind of case can also happen. That is what I know.
Mm-hmm.
Madam, can I interfere, madam?
Sure, sure.
The equal resistance force is also offered by the wall, madam, at that time.
Yes, that is
That
that is
K0
the
gamma K0 gamma H, that force is offered by the soil, and equal resistance force offered by the wall.
yeah, yes, that is
Hmm.
what I told. Like it is in a balanced state.
Yeah, exactly.
Yeah. So only when it is unbalanced, we can say either it is tense. That is only when there is an external additional pull or what you call like unbalanced pull or push. Only then we
Yes,
can specifically tell it as tensile or compressive.
yes, madam.
Madam, normally to measure the vertical stress, you are going to use a load cells, right? Some instrument called a load cells.
Yes, yes.
Hmm.
That is, load cells can be used to find the lateral stress also. That is for vertical actually.
Lateral stress, as far as I know, we can't measure lateral stress using that. Mm.
Uh-huh. Okay, that is
But we
only for
have
vertical
pressure
stress.
sensors. We have pressure sensors which can measure lateral stress as well.
Okay, okay.
It typically senses the pressure and then will give you the load acting.
Mm-hmm.
Yeah.
Okay.
And
Using
yes,
these also we cannot determine what is the pressure, what is the state of the soil, madam.
with what?
Using these cells also, load cells also, we cannot determine.
No, that is what. No, like it is in a state. Actually, it's in a balanced state. So it is
Mm-hmm.
neither in tensile state nor in compressive state. It's like balanced from either side. See, for example, in a similar way, if you tell in fluids, if you say there is Pascal's law, that is every point within that fluid. No, it will be like in a balanced state. It's not like
Mm-hmm.
force is not acting on in like the individual force. If you take that, may be tensile or compressive, but when
Mm-hmm.
you take ineffective or the
Mm-hmm.
net force or the net thing, when you take that is being balanced, that is getting balanced.
Okay, madam.
Yeah. And I think some one person had asked me during the last class, what is the practical situation when this passive earth pressure acts. I don't
Yeah,
remember.
last class, somebody
Yeah,
asked me.
yes, yeah. So
Mm-hmm.
I checked that, and so what I found was like it is not like every time we won't give a full retaining wall above the soil. Like some part of the retaining wall will be beneath the soil also sometime. Like usually soil will be only on one side, right? Only the backfill will be there. But in some cases there will be a layer of soil in front of this retaining wall also. In some cases, so some
Yes, madam. Sheet pile wall in the coastal area is the
yes,
best
yes, that's an
example for that.
example. So
Yes, madam.
likewise, some in some situations we will give like that. So that time the from the front end also the wall is getting a force, and there comes the passive earth pressure situations. Yeah.
Yes, madam.
Okay. So if there are no other doubts, then we can close the session for today.
Thank you, madam. Thank you very much, madam.
Thank you,
Thank
madam.
you.
Thank you.
Thank you.